From F to G, it's speeding up because it stops at F and it gets pushed back in the other direction. It's speeding up, the signs are the same. Here, it's slowing down, signs are opposite. And so now, remember that D to E and G to H, it's the same territory. It's the same force diagram regardless of which way it's moving. So D to E is 0 inclusive, G to H would be 0 inclusive. It's the same part of the same section of floor.
Wait, sorry, can you explain why that is 0 again?
What, these are 0? Once it leaves the wall. So at G is the first time after the wall, not touching the wall, which sounds redundant. So from G to H, the force diagram is I have normal force up from the floor and I have its weight acting down. Those are the only two forces. There are no forces left or right on it.
Okay.
So there's no net force horizontally, so the acceleration is 0. And we assume that these are equal in magnitude to each other, because if they weren't, it would be accelerating up or in or down, which doesn't make sense for a box sliding horizontally. Other questions up here. We've got, still have 1, 2, 3, we have 4 more boxes to do. All right, so what about from H to I? Or just on the other side of H to I?
Negative,
Why?
because it's got friction on it,
It does have friction out on it. Which way is the friction acting on it?
against it, that way,
That way?
yeah.
So everything, exactly, friction's acting on it, it's acting that way, absolutely right. What direction is that? Positive or negative direction?
Negative or positive direction.
Positive. And I think somebody over here said it too. It's positive at the end. And again, it's slowing down. And I've gotten into debates in the past about this one right here. This is the exact moment it stops, so I would contend that it is still accelerating at that moment. The moment after I, acceleration is 0, but at I itself, at that very moment it stops, there is acceleration, because the velocity did change in that moment. And all we have left is the beginning of the problem, from A to B.
Positive?
Why?
It's speeding up.
Speeds up from A to B? What would cause it to speed up?
Because it starts at that time.
It's already moving at the beginning of the problem. I don't know how it got started moving, but when the problem begins, problem starts with box moving to the right,
Okay. There's no other force acting upon it.
right? Therefore,
0?
0. All right, so let's look at this a slightly different, oh, Naveen.
In point I, the box stop I.
At I, it stops.
Yeah.
Yes.
So why acceleration positive? It
Because-
has to be 0.
The moment just before it stops, it's moving. It hasn't, just before time I, it has not stopped yet. At time I, it does stop. So there is a change in velocity in that moment.
You said your moment box stop.
Right.
H, in H, it's just before it stop. But in I, it's a stop.
It is stopped.
Yeah.
But I am contending that from that moment before it stops to when it stops, my velocity changes. It's going from something not 0 to 0. And since my velocity changes, there's acceleration. That's my argument. If I went to the moment just after it stops, acceleration is 0. So in that last moment, acceleration is realistically is small. But I would say it's still not 0 until just after. Other questions right now? All right, so let's look at it slightly differently. I'm just going to make up numbers here. So let's start off going to the right at positive 15 meters per second. So it's cruising along at 15 meters per second. At point B is when it starts the friction. The velocity has not changed up till here. So it's still positive 15 meters per second. Then it starts to slow down. By the time it gets to D, it's going positive 5 meters per second, because it does slow from B to D. And then it maintains that 5 meters per second because there's nothing stopping it from D to E, so it's still going at 5 meters per second. At time F, it stops, so it's going 0 meters per second. From F to G, it speeds back up, but now it's going in the negative direction, negative 5 meters per second. And it's going to maintain that till it gets to H. See if I can write that marginally better. And then at time I, it's stopped. Any questions about the progression of the numbers, where it slows down, where it speeds up? So now let's look at the change in velocity. Oh, I have another color somewhere. There we go. Go purple. There. All right. So my change in velocity from A to B is what? I'm looking for a number. If I go from 15 meters per second to 15 meters per second, what's my change? 0. So this is my change in velocity. Remember that change is always final minus initial. All right, so from 15 to 5, what is my change? Close.
-10.
Yes, negative. Negative 10 meters per second. Right. I can hold out 4 more minutes. All right. From D to E, what is my change in velocity? From E to F,
Negative 5.
from F to G, I'm going from 0 to negative 5.
Oh,
It's final minus initial would be negative 5 minus 0. So it's negative 5, as I heard some people say. And then from G to H,
Negative
And then from H to I, I heard a negative and a positive. It's one of those. Well, let's do the math. Final minus initial, it's 0 minus -5. Adding, so it's positive 5. Those are in purple I have my change in velocity. The change in velocity and acceleration always have the same sign. So it's 0 to start with, then it's negative, 0 to start with, then it's negative, then it's 0 again. It gets to the wall, it's negative. Bounces off the wall, it's 0 again. And then from H to I, it's positive. Just another way of looking at the exact same thing. So down here, just for completeness here, velocity is positive from A to F, parenthesis. It's 0 at F and I, and then it's negative from F to I. And then acceleration, it's positive only at the very end, from H to I, including I. It's 0, A to B, and then D to E, and G to H. Oh, wait, hold on. Yeah, G to H. Oh, so D and E are included here. And then positive. Oh yeah, I got, and then negative. B to C inclusive. Sorry, try that again. Including B, excluding D. And then B to G exclusive. And that's a square bracket here. If you're going to go with this notation down here, please make sure it's clear what your parentheses and your brackets look like. I've had some where I just can't tell, or the person who changes his mind, like I did just then, where you get something like that, and I'm going, or. I generally make a judgment call, and no one's ever come up and said, that was supposed to be a parenthesis. So I'm assuming I guessed correctly, or the person was so confused, they had no idea. All right. I know what you're thinking. You're going, yeah, but how can you top this? This stuff is so great. Can it get any better than this? Well, I guess on Wednesday, after the quiz, we will start doing some equations and number crunching and using the calculator or using your heads, whichever works. Using your fingers and toes if you need to. Have a wonderful day.